All right. Okay, good. So I have these different sets of relationships with parallel lines and transversals. And the first one, well, firstly, let's do this. I'm going to make this line kind of thicker right through the middle. And that's because these sets on the left are congruent. The relationship is congruent. So let's write congruent somewhere up there like that, congruent on the left side, and on the right side we have supplementary on the right side. And for those of you wondering, supplementary is well, that's a fancy word for any two things or even three things, but things that add up to 180 degrees. So I'm going to write here, just to help me remember, adds to 180 degrees. Okay. All right. Vertical angles. Okay, let's look up at this picture here. Let's come up with a couple sets of vertical angles. Vertical angles are just any angles that are directly across from each other at an intersection. So in this case, I can see it looks like angle 1 and angle 6 are vertical angles. So down here I'm going to write angle 1 is congruent to angle 6. And that's because vertical angles are congruent. Now I know what you're thinking. You're thinking, well, Mr. Bywater, aren't there several other sets of vertical angles? And to you I say, yes, there are. For example, well, does someone else want to give me an example? Anna? Anna says angle 5 and angle 2. I agree. That's another set. Let's write it down. Angle 5 is congruent to angle 2. And this funny looking L is just a way to denote angles that I'm talking about an angle. And there are others. Jackson, can you give me another set of vertical angles? What do you think? McKenna? 7 and 4, absolutely. We could say that. Angle 7 congruent to angle 4, absolutely. And there's one more set. I'm going to go ahead and have Ricky point it out to us. What is it? Angle 3 and 8, good. I kind of sometimes call this the reflection angle because it's just directly across. Yeah, and they are congruent. So there's a little trick for you. Next little trick for you is this other relationship, corresponding angles. Very same idea as corresponding sides when we're talking about congruent or similar shapes. Corresponding angles, here's how I like to identify these. I like to look at my parallel line and transversal as two separate intersections. There's one intersection, there's another intersection. Now, pairs of angles that fall in the same corner of their respective intersections are corresponding. So, like in this case, I can look at angle 1 and angle 3. See how those are both in the top left corner of their respective intersections? I think that's the easiest way to identify them. Anyway, corresponding angles are congruent. So I'm going to come down here. I'm going to say angle 1 is congruent to angle 3 in this case. And anyone willing to point out another set of corresponding angles for us? Go ahead, McKenna. Okay, angle 5 and angle 7, yeah, those are both in the, it looks like, bottom left corner. 5, oh, or sorry, yeah, the bottom left corner looks to be the same in both. So yeah, angle 5 is corresponding to angle 7, and corresponding angles are congruent, which is good. And I got two other sets in here. I'm just going to go ahead and say those verbally. If we had 1 and 3, 5 and 7, we also have angle 6 and angle 8. Those are also corresponding angle measures. And then we also have angle 2 in the top right corner and angle 4. Those would also be congruent. So there's your different kinds of congruent relationships here. Now we got supplementary relationships. Now, this word adjacent, that's fancy talk for next to. Next to. For example, I might say that Dean is sitting adjacent to Sean. I might say that Anna is sitting adjacent to Ricky. That's all it means. Adjacent is just next to. So if I look up here and I'm talking about, let's talk about angle 1 again. Let's talk about angle 1. And I could ask the question, what angle is adjacent to angle 1, Chloe? Yeah, there you go. And they are supplementary, so that means I can say this. Angle 1 plus angle 5 is equal to 180 degrees because they're adjacent. Or, yeah, because adjacent angles are supplementary. And there's another angle that's adjacent to angle 1, though. What is it, Emra? Yeah, angle 1 and angle 2, those are definitely adjacent. I could say angle 1 plus angle 2 is equal to 180 degrees. Absolutely. And there's several other examples. Let's point out one more for me. Go ahead, Willie. Okay, angle 3 and angle 4. Absolutely. Those are adjacent supplementary angles. Good. All right. Okay, boom. And there's several others. And it turns out, folks, that, hey, if all you knew were these 3 vertical angles, corresponding angles, and adjacent angles, the adjacent supplementary, if those are all you knew, you can always find every angle in a situation with parallel lines and a transversal. Same side interior is kind of like a shortcut that combines these together in a way. Basically, if I have parallel lines and a transversal, if I look at just my interior angles, and by interior I mean angles that fall inside the parallel lines, if they fall on the same side of the transversal, those are also supplementary. So I could take a look at, well, angle 6 and angle 7. These are both interior angles, and they both fall underneath the transversal. So these two angles are same side interior. They add to 180. So I could say angle 6 plus angle 7 is equal to 180 degrees. And yes, I can see Kaysen over there thinking to himself, Mr. Bywater, isn't there another pair of same side interior angles? And yes, Kaysen, good job. Angle 2 and angle 3 are also same side interior. They add up to 180 degrees. Okay, question, Ricky.
Can we do like angle 1 and angle 8?
Ooh, well, there is a relationship that we haven't written about, but there is a relationship, but it's not supplementary. They are congruent, as it turns out. They are congruent. But good question. Yeah, there are other relationships we could identify here, but I think these are the most helpful. But yes, there are other relationships out there. Good question. Alrighty then.